And for our last question of the review, the last toughest question that the spring class had, we have a formula over here for the decay of a radioactive isotope that looks similar to the continuous compound interest formula with some values plugged in, although we've got a negative exponent here. So part A, time of 10 years, that's being plugged in for T. You're just going to be calculating. You may have a calculator that lets you type this in all at once, but if you don't, exponents would be before multiplying by the 600, which means we'd have to figure out what that number is in the exponent. E to the negative 0.43 power is about 0.6505 090 65050 90947. So multiplying that by 600, I'm getting 390.305 4 5 6 8, and we're supposed to round to the nearest hundredth. That 5 in the thousandths place is going to round that up to 390.31, and since this is an amount, the initial amount was in grams, so this will also be in grams. Now, in part B, how long will it take the initial sample to decay to half the original amount? The original amount was 300. In 10 years, it is closer to a quarter, I guess, of the initial amount that is decayed. So I expect this is going to take longer than 10 years. It's worth pointing out that in 1996, oh, never mind. Okay, so half the original amount. So our future, or quote, final amount. The initial amount is still 600. What's unknown this time is the value of T. And it wouldn't have mattered whether we started with 600 or 800 or 1,000 or 1,562. Your first step would be to isolate part with e to some unknown power by dividing by 600. Solving a question like this would always have the next step being e to that unknown power equaling 1/2. Taking the natural log of both sides, it's going to cancel stuff on the left. Because it's the same base. Divide both sides by negative 1/2. sorry, by negative 0.043, that is. Again, you may have a calculator that lets you put this in all at once. If you do, terrific. Otherwise, well, 1/2 is 0.5, so natural log 0.5. That's a negative number, about 0.69 something, but I'm not going to round it, not yet. But by negative 0.043, I'm coming up with t is approximately 16.11970187. That was also supposed to be rounded to the nearest hundredth. The 9 is going to round that 1 up to a 2. We have approximately 16.12 years is what it would take to have half of the original amount. And that concludes our look at the toughest questions from the spring final. If you have questions, contact me. See what we can do to clear things up. Have a good one.